So next, I will talk about what are some of the energy savings measures that you can have in the air handling system or the air side. So in air handling system, the only thing that consume energy, right, okay, is the AHU fan. Okay, please write this down. Okay, maybe it's not in the slide. Okay, it's your AHU fan. Okay, it's your AHU fan. So maybe let me write this down. So over here, this one is your AHU fan. So your AHU fan is the one that consumes energy inside the air handling system. So to reduce the consumption of your fan, there are two ways, okay? Because energy is a factor of power and time. So it's either you reduce the power consumption or you reduce the running hours of your fan. Okay, very straightforward, okay, because of this equation. So the area under the graph must be smaller, okay, if you want to save energy. So let's talk about the more straightforward one, is to reduce the running hours, okay. So for example, instead of switching your AHU for 10 hours, if it's possible to achieve thermal comfort at 9 hours, okay, or 8 hours, then do it. Okay, so you can maybe start the AHU fan at a later time. Let's say your occupants haven't occupied the space, you don't have to switch it on so early. Okay, you may try to adjust it. Start the AHU 1 hour before peak hour, okay, to purge the air. Okay, so usually right, before the occupants enter a space, they will try to purge the air in the room, okay, overnight. So that's why they will start 1 hour before peak hour to purge the air. So, or also to pre-cool the air. So this is some of the challenges you may face. Although you want to start the AHU at a later time, but you cannot do it because of good indoor air quality practice. Okay, you will have to purge the air first. Or you can try to stop the AHU at an earlier time. Okay, so when there's no more occupants in the room, maybe at 7 o'clock, you know that the office is empty. Okay, then you cut off the AHU fan. Okay, so because people are very sensitive to stagnant air, okay, so usually you cannot switch it off too early. Okay, you cannot switch it off too early. You have to ensure that there are no more occupants. Okay, so if you know that maybe a particular office, they usually release at a much earlier time, then it's possible to do that. If not, it's quite a challenge to use this strategy as well. Okay. And for example, for weekend, okay, you know that weekend, right, maybe only certain days there will be occupants. Okay, certain days because of OT or because of some event that you need to switch it on. Okay, then it should be on a on-demand basis. It shouldn't be on weekly. Okay, it shouldn't be by a time schedule, but instead it should be a on-demand basis, such as it will discourage people from switching on the AHU for extensive hours unnecessarily. Okay, and for public holiday, it's good to go and review your public holiday schedule. Make sure you switch it off during public holiday and weekends. And for the other method is to reduce the power consumption. So to reduce power consumption, right, if you look at this equation carefully, okay, mainly you will try to reduce your QS and QL. So the most straightforward way is to reduce a cooling load, okay, in the building, okay, in the space. So you can try to reduce the solar heat gain into the space, maybe by installing blinds, okay, or using a solar film, okay. Reduce unnecessary plug load, okay. So things that generate a lot of heat, okay, you may start to switch it off, or your photocopy machine should always go to standby mode and things like that. Reduce unnecessary fresh air intake, okay, or unnecessary infiltration air, okay, those outside air, okay, try to reduce it, and avoid overcooling the space, okay. That means don't set the set point to a very, very low temperature. Okay, all this will cause your QS and QL to increase if you don't do that. Okay, alternatively, okay, if your delta T and delta W, okay, delta omega is increases, okay, and if your load never change, actually your mass flow rate will start to reduce. Okay, your mass flow rate will start to reduce. So what happens is So if you look at the equation, so Qs is equal to m dot C air delta T. So in order to generate less amount of power in the fan, you will try to reduce this mass flow rate, okay, of the air. But to reduce the mass flow rate of the air, you have to increase this value. Okay, your delta T must increase. So for example, if your return temperature is 24 degrees Celsius, okay, and your supply temperature is 15 degrees Celsius, so your delta T initially is 9 degrees Celsius. But in order to have a lower fan speed, you may try to increase this value to maybe 11 degrees Celsius. But to achieve that, your supply air, instead of 15, it has to be 13 degrees Celsius. That means you must throw in air that is much colder. Okay, much colder. Okay, so this one is called a low flow, high delta T method. Okay, low flow but high delta T. But this method may not be recommended, okay, because this value will have to be very cold. Okay, so your humidity ratio will be very cold. So by trying to save energy at the fan, you may cause a higher chilled water flow rate at the cooling coil. Okay, your cooling coil will have to have higher chilled water flow rate and a lower chilled water temperature. So your chilled water temperature, instead of 7 degrees Celsius, now it may have to go lower. So both will cause an increase in energy consumption at the water side. So you are saving energy at the air side, but you are wasting energy at the water side. So you will have to consider this carefully. Okay, do your balance. Okay, so VSD will also reduce the fan speed when your static pressure is above the set point. Okay, so static pressure set point, you can try to adjust to a lower value. So if your static pressure is adjusted to the set point is adjusted to a lower value, your VSD will be ramping down the fan speed in order to meet the set point. Okay, but that is only possible if it doesn't really affect the thermal comfort. That means there's still enough air to go to the very, very last room. Okay, it still generate enough pressure and enough flow to the very last room. Okay, and the last method that you have to do is make sure your cooling coil in the AHU, okay, is very clean. So your cooling coil, make sure there's no scaling. Okay, you have to do your regular maintenance to clean the cooling coil surface. Okay, the cooling tube. Okay, so because of that, then the heat transfer between your air and your water can take place effectively. If your cooling coil is dirty, it's like a layer of dirt on top. Okay, the air that comes out after passing through the cooling coil will have a very high temperature, so it will not be cooled down effectively. Okay, so these are the few ways that you can actually save energy in the air handling systems.